All right, here we are in the 3.2 Go from the Mathematics Vision Project, old version of the curriculum. And this is another Math 1 topic that we're reviewing where we evaluate functions. So as we're doing this, we're just kind of aware of, last year was COVID. How am I doing on this Math 1 topic? Something I'm supposed to be very solid in Math 2 by the time I take Math 2. So we're just aware, right? That last year was an interesting year and some of us are stronger in certain skills than others. So let's see how you're doing. Because they're asking us for 3 different inputs, we're actually going to have like 3 problems within each problem. So number 19 has 3 parts, number 20 has 3 parts, etc. 2 of the parts, sorry, I just said 3 inputs. 2 of the parts have inputs, meaning they're asking me to input -3 in for x, and they're asking me to input half in for x. But one of the problems is an output problem. This middle one gives us the output and asks us to solve backwards for the input. And I'm using these terms loosely as if we understand them, so let me just define them real quick up here at the top. An input is our x value that we're plugging in for x, also known as our domain. And our outputs are the y value or the value of f of x, also known as our range. So we want to become familiar with all of that academic vocabulary, that what it means as we're doing this. So let's go do the first one, which is a nice linear equation. How do I know it's a linear equation? Because it's just a 2x minus 7, a plain x. It's in mx plus b form. Plugging in the 2 inputs, first we're putting in a -3. So this is 2 times -3 minus 7, which is -6 minus 7, which means f of -3 equals -13. Trying to see how much space you have here and how you're going to write this. All right, I'm going to drop down and do the next input problem. F of 1/2 equals 2 times 1/2 minus 7. What's half of 2? That's just 1 minus 7. So f of 1/2 equals -6. Now for an output problem, it means we're being given the answer already, the output on the other side of the equals. So 21 doesn't plug in the same place that we did last time. 21 plugs in on the outside, and then we solve backwards in this function. So we add 7 to both sides. I don't know where we're going to fit this. I think I need to put this on the left. Hang on. Two x minus 7. We add 7 to both sides and divide by 2. We were given an output this time, and we just solved backwards for the input. You can write your answer as x equals 14 or f of 14 equals 21. All right, next one is an exponential function. How do we know? Because the variable's in the exponent, because it's multiplying. Okay, so doing this one, we're being given an input of -4. So 3 to the power of -4 times 2. Remember that a negative exponent means repeatedly dividing. So 3 to the -4 becomes 1 over 3 to the 4th times 2. Or 1 over 3 times 3 is 9, times 3 is 27, times 3 is 81. 1 over 81 times 2 My final answer comes out to g of negative 4. Hang on, I got an extra negative in there somehow. Equals 2 over 81. If you got the decimal version of that, that would be fine as well. G of 1/2 means we're plugging in a power of 1/2. 3 to the 1/2 power times 2. Well, anything, number 3 to the power of 1/2, that becomes a radical. Anything to the power of 1/2 becomes the square root of 3. That denominator 2 becomes your index, the square root of 3. So this is the square root of 3 times 2, or 2 square root of 3 if we reverse that answer. So we write g of 1/2 equals 2 square root of 3. If you got me the decimal version of that one by plugging into Desmos, that's fine as well. All right, the output problem, I'm going to go make space for up here, of 162. Say this is number 20, g of x equals 162. So my output is 162, and my function is 3 to the power of x times 2. So I can solve this first by dividing by 2, and that means that 2 goes into 162 81 times, and then that leaves me, these cross out, 3 to the x. So I'm asking myself, 3 to what power equals 81? 3 times 3 is 9, times 3 is 27, times 3 is 81. That means that this has to be 3 to the 4th. My x is 4. But the way I write this from Math 1 exponential functions is I convert this 81, 3 to the 4th equals 3 to the x. And because those are two functions now, two expressions with the same base, I can see that this x has to be equal to this 4. So the answer for number 20, the output problem, is x equals 4, or you could also write it as g of x, meaning g of 4 equals 162. However you want to write this answer. All right, next one is also an exponential function with a percent multiplier. So we're going to say 210 times 1.08 to the power of 12. And so for this one, we're going to need to use Desmos. So go ahead and click on a new tab right now. And type in 210 times 1.08 to the power of 12. So that leaves me 528.81. 500, sorry, we're going to round to two decimal places. So 528.82. Okay, the next one's the output problem. I'm going to go do that up top where there's space. So let's just figure out this next one on Desmos first. 210 times 1.08 to the power of 1/2 instead of 12. So go ahead back to that tab. Now, when you type this in and say to the power of, you can do 1/2 or 0.5, right? Which equals 1/2, whatever you're comfortable with. So 218.82 218.24, 218.24 when I round that one. I'm rounding to 2 decimal places. Now, by the way, since we're rounding, I just want to be clear that these little equal signs are not equal signs. They need to be approximation symbols, or bumps, as I call them in class, because we're rounding. And when you use the approximation symbol, you're telling the reader that you rounded that answer. Okay, the 420, let's go over and check that guy out. 420 equals 210 times 1.08 to the power of our unknown t. So we're going to divide both sides by 210. So we get 2 is equal to 1.08 to the power of t. Now, when I try to solve for an exponent that is unknown, we actually are supposed to be using something called a logarithm, but you're not going to learn those until Math 3. So we have to troubleshoot, what am I going to do here? So let's go check this out. 1.08 to the power of something that equals 2. So I'm just going to throw in a 5. Do you see how that equals 1.469? Okay, I need to go bigger. Let's try 6. Let's try 7. Let's try 8. Let's try 9. Woo! 1.9999, that rounds to 2. That's my power. So I just did the guess and check method to get that t would equal 9 because I don't know logarithms yet. I don't know how to use that kind of a function to work backwards to get that variable. So we just kind of test it out to see 1.8 to the power of what would equal t. All right, down here at this quadratic, how do I know that this is a quadratic? Because it's got an x squared. So we say negative 5 squared plus negative 5 minus 6. That gives me 25 minus 5 minus 6. So 25 minus 5 is 20. 20 minus 6 is 14. So we say h of negative 5 equals 14. And that's our output. Let's go do the output of 1/2. 1/2 squared plus 1/2 minus 6. That's 1/4 plus 1/2. And by the way, I'm going to convert that 1/2 into 2/4. And I'm going to convert the 6 into 24/4. So I can actually use common denominators and actually add these. So 1/4 plus 2/4 is 3/4. 3/4 minus 24/4 is going to give me negative 21/4. H of 1/2 is equal to negative 21/4. Okay, h of x equals 0 means I'm going to set this quadratic equal to 0. I think I'm going to do it down here. Oops. So I'm going to rewrite it, x squared minus x minus 6. You see this from up above? They're telling us that the output is 0. Well, we just learned this last chapter how to solve a quadratic by factoring. So we want to say what times what equals x squared minus x minus 6. So let's go do this. What times what is negative 6 and subtracts to give us negative 1? You got it, 3 times 2. The 3 gets the negative so that it yields -1. So I'm going to say that my factors are x minus 3 and x plus 2. And now I'm going to solve. Using zero product property, I'm going to I'm going to set this first factor equal to 0 and then add 3. I'm going to set this second factor equal to 0 and then subtract 2. And I get my two solutions. X equals 3. Oh my gosh, sorry guys. And x equals -2. So way up here, what was all this work for? X equals -2 and 3. I got two solutions for that guy right there. Okay, next is a nice linear again. How do I know it's linear? It's got a plane x. So we're going to go k of -7, means we plug in -7 as our input. -5 times -7 is 35. So we get that k of -7 is equal to 44. I'm going to skip the output to do down at the bottom. -5 times 1/2 plus 9. That makes -5 halves. Let's convert 9 into halves. 9 could be also rewritten as 18 halves. And 18 minus 5 is 13 halves. K of 1/2 is 13 halves. Okay, let's go do the output. We're going to set it equal to 0. So 0 is equal to -5x plus 9. We minus 9 from both sides and divide by -5. I'm getting that the input x is equal to 9/5. That's for this guy right here. Last but not least is another exponential. For this one, we're going to have an input first. It's 5 to the -2 power times 2. We know that negative exponents become 1 over 5 halves, or 1 over 25 times 2. So I just get that m of -2 is equal to 2/25. Let's plug in a half power. 5 to the 1/2 power times 2 is equal to square root of 5 times 2, or 2√5. And last, we're being given an output of 1. Divide by 2. We're saying 5 to what power would equal 1/2? So again, I don't know how to use logarithms yet. I'm not in Math 3 yet. So I have to just go into Desmos and kind of test this out. 5 to 1/2 power. I'm sorry, 5 to what power would equal 1/2? And so let's just test out a number like 5 -2. That's not 0.5. 5 -3. Okay, that's getting smaller. 5 -1. 0.2. 5 -0.25. 5 -0.5. Ooh, there we go. 5 to the negative 0.43 equals 0.50, and that rounding gives us that 1/2. So 5 to the negative 0.43. That means that my x is negative 0.43. And later you'll learn how to use logarithms to get that much faster than that guess and check method. Let me go write this up where this belongs. X equals negative 0.43.